Finding reference angles for radian measurements. All right. If you skipped the previous video where we talked about radian mental math because you're like, oh, I don't need that, please go watch it real quick, or at least like scan this worksheet and get a sense of where we are. We're going to do the same thing we did for degree reference angles. We had the same picture. We're going to do the same thing, but we're just going to do it in radians now. I have written up here what the reference angles were in terms of degrees, and they are not much different at all from the radians. It's just we have to change degrees into radians. That's the only difference. So real quickly, let's see, 0, this is going to be pi over 2, pi, 3 pi over 2, and then this guy is also, he's 0 and he's also 2 pi. So instead of this being 180, we're thinking of it as pi. So our reference angle in quadrant 1, instead of it, or it's the same, it's just theta. It's theta, but theta's in radians. So just the same. Oh, let me mention here, this is important to note, much like with degrees, and I'll kind of scroll back to this video real quick, much like with degrees, it's really important that theta is in the first revolution. It needs to be in the first revolution for the formulas I'm about to write down to work. So theta must be between 0 radians and 2 pi radians for these formulas to work. All right, quadrant 2, in degrees, we said it was 180 minus theta, 180 degrees minus theta, but instead of 180, it should be pi. So it's pi minus theta. In quadrant 3, instead of it being theta minus 180, it's theta minus pi. And then in quadrant 4, instead of 360 minus theta, it is 2 pi minus theta. So these formulas really not different. They're just in radians. That's the difference. All right. The process is identical. It's an identical process to finding the degree reference angles. Oh man, I even forgot to change this word. Radians. I'm going to pause that video and fix that on the worksheet before I post it. All right, I've made that change. So it's the same process as degrees. It's just in radians. And so instead of adding 360 degrees, you're adding 2 pi or subtracting 2 pi, depending on if theta is more than 2 pi, 2 pi degrees. That also should be fixed. Errors everywhere. It should just say 2 pi. If theta is more than 2 pi, we subtract 2 pi until the angle is between 0 and 2 pi. If theta is less than 0, we add 2 pi until the angle is between 0 and 2 pi. All right. So we're finding a reference angle. We need to start by making sure our angle is between 0 and 2 pi. For this fraction here that has a denominator of 5, 0 is the same thing as 0 pi over 5. And 2 pi is the same as 10 pi over 5. So we are looking for the numerator to be a number between 0 and 10. Right now, the number we have is -9, so we need to add 2 pi. So we are going to add 2 pi, which is the same thing as adding 10 pi over 5. So add 10 pi over 5. -9 plus 10 is 1. So we get pi over 5, 1 pi over 5, but pi over 5. 1 pi over 5 is between 0 pi over 5 and 10 pi over 5, so that's the angle we're going to work with. I'm going to draw a picture. And just like the radian mental math we did in the previous video, I'm going to label this thing using denominators of 5. So let's see, something pi over 5. And then I'm using an iPad so I can just duplicate this quickly. All right. So half the denominator is 2.5. So I'm going to add that each time I move counterclockwise. So I start with 0 pi over 5 plus 2.5. So 2.5 pi over 5 plus 2.5, 5 pi over 5 plus 2.5, 7.5 pi over 5 plus 2.5, 10 pi over 5. And you might say, Professor Cook, I know that where this one was without doing this. Yeah, but it's good practice, so do it anyway. All right, pi over 5, that's really 1 pi over 5. It's in quadrant 1. And that's nice because in quadrant 1, the reference angle is just the regular angle. So the reference angle is pi over 5. I want to make a note here, make a quick note here, that this is the reference angle for theta equals negative 9 pi over 5. It just so happens that any coterminal angle with negative 9 pi over 5 will have the same reference angle. So it was the reference angle for pi over 5, but it's pi over 5 is also the reference angle for negative 9 pi over 5. All right, so then let's look at 29 pi over 10. We need it to be between 0 and 2 pi. So let's convert that to denominators of 10. So we have 0 pi over 10 and 20 pi over 10. 29 is bigger than 20, so we need to subtract 2 pi until we get something between 0 and 20 in the numerator. So minus 2 pi, which is the same thing as minus 20 pi over 10. So 29 minus 20 is 9. 9 pi over 10. We ask ourselves the question, is 9 pi over 10 between 0 and 20? Is 9 between 0 and 20? And the answer is yes. So that is the angle we're going to use, 9 pi over 10. And we want to find a reference angle for it. I'm going to draw a picture just like I did before and just like I always do. I'm labeling with denominators of 10. Half of 10 is 5. So these are all going to be something pi over 10. 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 You always start with 0 right here, so 0 pi over 10, then add 5. 5 pi over 10, add 5. 10 pi over 10, add 5. 15 pi over 10, add 5. 20 pi over 10. So 9 would be here in quadrant 3. It's between 5 and 10. This is 9 pi over 10. Our reference angle is right down here. So our reference angle is going to be, you can look at the formulas above. I just like to look, like I said, I like to just derive it each time. This is 180, this is theta. So we're going to take 180, we'll subtract out 9, not 180, pi. We'll take pi and we'll subtract out 9 pi over 10. And that will give us this leftover bit here. Pi minus 9 pi over 10. And instead of pi, I'm going to replace pi with 10 pi over 10. Let's do that. 10 pi over 10, because that's equal to pi. And then we can just do 10 minus 9 is 1. So pi over 10 is our reference angle. Pi over 10. Boom. And there you go. Those are reference angles for radians. So hopefully that trick helps a little bit. I find it quite useful, saves me a lot of time in not using my calculator. That's all I have for this time. And in the next video, we are going to do some fun stuff. We're going to find trig value, given information about an angle. I think it's some of the funnest stuff we have to do in trig. So I'll see you then for that one. All right. Good luck. Bye.